Welcome to another section of the module Basic PLC. Today we are going to be looking at the PLC hardware. The PLC hardware. In our previous lesson, we saw various types of PLCs, and then we agreed that the PLC is also an industrial computer. And every computer definitely will be made up of two sections, okay? The PLC will have the hardware, just like the computer will have the hardware, and also what? The software portion. Right, today we are going to be looking at the hardware. In another lesson, we are going to be looking at the software, okay? Now, today we want to define what is the hardware, what is PLC hardware. Being conversant, or I believe many of you would have been a computer student, and then you know certain things to an extent about computer. And then hardware components are PLCs, or rather, hardware components are those physical things that you can touch. Those physical components that you can touch in a computer are called the hardware. And same thing with the PLC, those areas that you can actually touch are the what? Are the hardware components of the PLC. What are they? They are the power supply. Okay, you can touch the power supply. The input and output modules can be touched, as well as the programming device. Those constitute the hardware of the PLC. Today, I also said in the last lesson that we are going to be looking at the Allen Bradley PLC, the SLC 500. And today, I've brought the PLC. This is known as the Allen Bradley SLC 500 PLC. And it will be helping us to study the hardware of the PLC. The PLC has basically common features. So what you see in this PLC, you can also find it in other brands of other PLCs. Talking about the power supply, okay, I did say that we have the power supply, okay? So the power supply of the PLC makes use of what? 24 volts, okay? This is the 24 volts. This is the PLC's input voltage, or the voltage that supplies the PLC. Now, this PLC, this is the software, this is the power supply, okay, of this SLC 500. This is the power supply. In this power supply, the AC is stepped down and converted to a DC. So if you have a 20 volts AC supply, it is converted to what? 24 volts DC power supply. So this does the what? The conversion. It converts the PLC because the PLC is connected to the mains. Okay, we connect this PLC to the mains, and then this PLC, this does the conversion to 24 volts and feeds the remaining parts of the PLC. We also mentioned that it has the CPU. The CPU is not different. It has the central processing unit. The central processing unit is this module before you here. This is the CPU. I open it. In this CPU, this is a modular PLC. Remember in the last class, I did say that modular PLCs can be expanded. So these are expandable, and they come in slots, okay, or racks. Some may call it rack PLC. Some may call it rack PLCs. So these are racks, okay, embedded in a chassis. There is a metallic frame that is made up of aluminum that has a shining. It's known as the chassis. So these are the racks, and then these are plugged into the chassis. So these are spare slots, which I shall open. Okay. So this is the chassis, if you can see it. Okay. If you can see this is the chassis. This is the metallic aluminum plate I was talking about. And then you have the modules. Okay. These are spare modules. So it means that I can detach these modules. Remember, these are part of the advantages of the PLC, where I did mention that it is easier to replace as part of it. So, which means if a module goes bad, I can actually pull out this module and replace it. So it is like a plug and play. So we don't have to go about, repairing this. So we can have a spare module. We replace the module and reconfigure, okay, the PLC by entering the details of the new modules that we may have replaced. Okay. Now talking about this, the modules, these are the input modules. Okay, this section is the input module, and we have the output module. Now this is the digital input module. So under the other part of the hardware, we have the input, and then we have the output module. Under the input module, we could have a digital input, we call it DI, the digital inputs, or we could have digital output, DO. So you can have it as DI or DO. So DO means digital input and digital output. So for this PLC, this is the digital input, this is the digital output. Now we also have analog inputs, AI. Okay, so we call it the analog inputs, as well as what? The AO, analog what? Analog output. So there are signals which you can get from the input and output devices connected in the field. By the field, I mean in the factory floor. Those devices can be connected in the input, digital input or digital output, depending on the signal that is being received. If it's a digital signal, then it is connected to what? To the input digital module. If it's an analog signal, you can connect it to what? To the analog input module. So by digital, we mean ones and zeros, ones and zeros, ones and zeros. And then analog signals can vary. If it's a current signal, it can vary between 4 milliamp to 20 milliamp. If it's a voltage signal, it can be between 0 to 10 volts. And if it's a pressure signal, it can vary from what? From 3 psi to 15 psi. So these are just standard process signals that are used in the industries. So these are just analog. Remember, the real world we live in is analog in nature. So having explained this, we are going to come back to this. We want to now look at what are the devices that constitute the inputs to a PLC. Okay? So some of the devices that constitute the inputs to the PLC. So when we know what are the inputs, we can also decide the output and make the right connections. Because when we don't know things that are the input or output, we can take the output device and connect it to the input device, and then something goes wrong, or we will not get the required signal or desired result that we want to get. Number one is we have sensors. Sensors are part of the input device, or it constitutes the input devices. Sensors are categorized in a lot of ways. It could be a proximity sensor. And these names are basically given by the job that they perform. So when you talk about proximity sensor has to do with what? Proxy, something that is near. So you can sense something that is what? That is near. Okay? We have photo electric sensors. So like the word implies, photo has to do with light. So you have probably it could be an infrared sensor, something that will send and then also have a reflector that can receive. So there are a lot of sensors in the market. So all sensors basically that they fall under the word, the input device. Okay? Also we have push buttons. You can have the push buttons. Okay, all push buttons are input to the PLC. We could have as well, we could also have switches. Different kinds of switches exist. Okay, we could have different kinds of switches, but the limit switch, okay, the float switch, the vacuum switch, the level switches. So all these kinds of switches are all input devices. What of output devices? What are the things that constitute output devices? Output devices includes things like solenoids. Solenoids are output devices, okay? Motors, electric motors are what? Are what? Output devices. We also have relays. We have actuators. We have valves. Many of them contains coils, okay? So these things have, they constitute outputs to the PLCs. We have fans. We have pumps. We have so many of them. All these are part of what constitutes what? The output devices. So these are examples of the input devices. So the next thing we shall look at, we'll look at the things that some of them, like I said, will be connected to the digital input and then digital output. Some cannot be connected to this, but rather to the analog output module. And some of them are all what? Are process variables. Process variables like pressure, level, flow, temperature. Some of them that sense this, they don't actually give out 0 or 1, that they don't give out digital signals. So such devices constitute inputs to what? Inputs to the input module. For example, you could have a pressure switch, you could have a level switch, you could have a flow switch. Okay, those switches are already digital signals. But if they give signals between these ranges, these are not zeros and ones, so it can be what? Can be connected to what? The input or output module, as the case may be. Now, we are going to be looking at the CPU in much details for this particular SLC 500. The CPU contains a communication port. Okay, we'll talk about PLC communication, or rather you read up the PLC communication from the content which has been given to you. Okay, this communication port here is the RS232 serial parallel connection. This is a serial connecting port. So it's a serial port. That's the RS232 communication port. And then we also have the Ethernet. We have the Ethernet. So this Ethernet is another form of communication that makes use of the Ethernet, not the internet, but mind you, is the Ethernet. So you can from here you can control the CPU, or you can save or download information to the CPU. So which means I can have several computers through a switch connected to this PLC using the Ethernet port. Okay. Now on this same device, we have some features written on the body. Okay. This model is the SLC 5/05. Okay. So we have the 5/05 and we have the 5/04. This contains the RS232 port as well as the Ethernet port, while this only contains the RS232 communication port. Okay. Then coming to what is written on the body, we have some of the things written on the body will only be activated, okay, when it is switched on. Okay, like the run, we have the run, in case you can't see it. We have the run, we have the FLT, okay, we have the force, and then we have the ENT. Okay, so these are indicators. And then we have the RS232. These are called indicators. Okay, so this tells you what is going on in the PLC. So when the PLC is running, this light will come on. Okay, when you download a program to the PLC, okay, you will now set it to run. And this can be controlled by this key, this little key here. Okay, so you can switch it to run, or the prog mode, or the REM mode. I'll talk about that in a short while. So another one there is the BATT. Okay, so this is another indicator there. So this means run. This is when there is a fault. This light will come on. Then this force means once there's an I/O that is forced. By forcing means that device on the field may not really be working properly. Okay, so you go and then you force the I/O. Okay, by forcing means that you are sending a signal. You are asking the PLC to actually overlook that device and pretend that it's either switched on or off. So when that is done, this light will come on, meaning that an I/O has been forced, okay, and needs to be cleared before further actions can take place. So this ENT is the Ethernet, okay? So this is the Ethernet. The Ethernet also means when you have that connection, when it's receiving signal from the switch or from any other connection like I explained. Then this RS23 is the serial communication port. Whenever you have it communicating with the programmer, you can see this light on when it's receiving information. And this BATT means battery, means the battery. So once the battery light comes on, you know that the battery is flat. So we'll talk much more about batteries when we go to the PLC architecture, because these are the things that can keep the memory on so that you don't lose data while you are operating the PLC. So that flashes to tell you that the battery is bad. Now, coming to the key path where we have the run, the REM, and the prog. What this means, we have the REM, or rather run, we have the prog, and we have the what? REM. So you have the key, this is the key. So the key can be touched, can be switched to this, either of this or this or this. So while you download the program to the PLC, what it means is that by the time I want the PLC to run, I will switch this to what? To the run mode. Okay? And then it begins to run. While I want to download to the PLC, I will do what? I will switch this to what? To the REM mode. So rather, the prog mode. That's the prog mode. That's program mode. I want to write a program to the PLC. And another terminology that is used here in the PLC is while you want to send information from your laptop, that's the programmer, or the PG, to the PLC, use the word download. Okay, not upload. You have to do what? Download. That's the PLC terminology. And when you want to extract information from the memory of the PLC, you do what? You upload to the programmer. So this is very important. By the time you begin to write programs, you may see them coming up, and then you use the same internet terminology, trying to upload a file or download the file from the net. So when you use that terminology, you have some errors, okay? So while you are writing that program, once it's time to send to the PLC, you download to the PLC. Some say write to the PLC. That is, some PLCs like the distribution. When you want to send information from the PG to the PLC, you do what? You write to the PLC. While for the Allen Bradley says you download to the PLC. So they all mean the same thing. When you want to take information, you do what? You upload from the PLC. So this is exactly what this does and how it operates. So these are part of the hardwares, these things that you can touch. These are the hardwares to the PLCs. Okay, so most PLCs you see in the industries are modular in nature. Okay, and the modules are printed circuit boards. When you pull this out, when you come to the center, you pull it out, or if you can see through it, you see a printed circuit board called the PCB. Okay, this is an enclosure that houses these modules. Okay, so in general, before you have to pull this out, you have to do is shut down the PLC so as not to, introduce static charges to the printed circuit board, which can actually damage the PLC. Okay, so this is one of the products of the Allen Bradley PLC. When you take a look at your screen right now, you see other products like the PLC 5. That is the PLC 5 showing on your screen, showing you this is an older version of the PLC before the other version. So the PLC 5 before the SLC, and then the one again on your screen is the control logics module. Okay, the control logics module is one of the latest from Allen Bradley. You can see the CPU there. You can see other modules like the input module. You can see the output module. You can see the communication module, okay, for communicating with other PLCs. And you can see the RS-232 and other things that we've just mentioned. So you can see it's a bit similar to the SLC 500. Now, before you again is the PLC circuit. I mentioned the printed circuit board. So that's an example of the printed circuit board showing on your screen. All right, so what is the advantage of using the modularity of a PLC? Okay, the modular systems are easier to troubleshoot and thus help minimize a lot of downtimes. Modular systems can be expandable, like this one. This is a 1, 2, 3, 4, 5, 6, 7. This is a 7-slot chassis. This is known as 7-slot chassis. So, but we are currently making use of 4 modules. 1, 2, 3, 4, 5. Rather 5. We are making use of 5. Okay. This is the power supply. You don't count it. So this is 1, 2, 3, 4, 5, and then 2 extras. So these are expandable. What it means is that we don't have anything connected at these points. So what it means that in the future, we want to expand. We have 2 slots where we can expand to. So that's what we mean by it is expandable. Unlike, as I mentioned in the previous class, a fixed PLC cannot be expanded. So it means that anytime you have more IOs in the factory where you work, okay, you need to expand the PLC, but then the PLC has to be modular, and then it has to be expandable. Okay, so it's easier to upgrade these kinds of PLC. So I've just explained to you the fixed versus the modular system. Whereas the fixed cannot be expanded, the modular can be expanded. Also showing on your screen is an example of a PLC made by Allen Bradley, which is the MicroLogix 1000 PLC. This PLC contains 32 IOs. So if you remember in the last video you just watched, I said sometimes the input and the output don't balance. So this is one example of a PLC that has 20 inputs and 12 outputs. So that's what is showing on your screen. So you can see the same indicators. When you look closely, you can see the power, you can see that of the run, the fault, and the false indicator, okay, showing on your screen. So this is a fixed PLC. It cannot be expanded, okay? Looking through the PLC, you can see the terminals in the next picture before you. You can see the terminals. The upper terminals depict the output terminals, and the terminals below depict the input terminals to the Allen Bradley PLC. So that's an example of the micro PLC. So I explained to you the backplane of the PLC, and I also want to tell you about the terminals. So these are the terminals to the PLC. These terminals are 16, okay? So we have, these are called terminal blocks, okay? These are terminal blocks. So you have 0 to 15. So each of these input devices and output devices are connected to the input and output modules respectively, okay? So terminal, this is connected to terminal 0, terminal 1, terminal 2, and so this can represent a sensor, this can represent a switch, this can represent a push button, this can represent all the examples of the input I had earlier talked about. And the output can also represent a valve, a solenoid, a relay, a contactor, an electric motor, and so on and so forth. So this is how it is connected in the terminal blocks. So these terminal blocks are embedded in the modules, and this forms the hardware of the PLCs, okay? So remember, I said the hardware is anything that can be touched and felt on the PLC. And we mentioned the power supply, the CPU, the I/Os of the PLCs, okay? And we listed also the components that make up the input and output of the PLC hardware, okay? So try your hands on some of the practice questions, as well as ask your supervisor in your factory to also show you some of the hardwares of the PLC that is obtained in your industry. So we'll end the lesson here until we see you next time on PLC operation and architecture. Thank you very much.